Hi, and welcome to Testing Genius. We are live on YouTube. Welcome, everyone. Thank you for being here. I'm Emma, the CMO at Agilitest, and with Archie from TestGear. Hello, Archie.
Hello.
So just to give you a brief overview of the event, so Testing Genius is a free online meetup for QA and DevOps who want to unlock smarter test automation strategies. So conference will start in just a few minutes. But before that, let me give you some very basic tips. So we have 3 conferences, 1 panel discussion. There's a Q&A at the end of each conference, so you can ask your question using the chat on YouTube. And we'll make sure to share them to the speakers. You can also use the hashtag TestingGenius if you want to, spread the word on social media. And conference recording will be shared tomorrow by email. So that's it. Thank you for joining us. Sit down, relax, and enjoy Testing Genius. So the first conference, we are going to start with Attila. So Attila is going to join us.
Hello, everybody.
Hi.
Nice to meet you.
How are you doing?
Thanks, fine. Bit nervous, but yeah, let's see how it goes.
It's going to be okay. So we will talk about insights into testing and IoT embedded software and how to basically avoid any failures. So the mic is yours. Enjoy.
Thank you very much. Hello, everyone. So as mentioned, my name is Attila. I'm speaking to you from Germany, and I am a validation engineer at Konux, responsible for the embedded software testing. So before we would deep dive into the topic, let me just give you a little overview what Konux does and what is the vision of the company. This is really crucial so that you can understand the topics behind our test. So Konux said that, or our company says that we would like to transform the railway operations for sustainable future. Or to put it to a simple words, we want to make sure that people start to use cars instead of trains, as this will really help our environment. A very interesting fact, when I came to Konux, I realized I was shown these statistics my first day, actually. It's way better for the environment if you take a train as if you are a steak person and walk. So it's more emission friendly. So as you know, most of the emissions and the whole global warming is a certain issue. And definitely like 23% of the emissions, global emissions, comes from transportation. So if the train...
Sorry to interrupt you, Attila, but we still cannot see your slides. Don't forget to share your screen.
Oh, that's an excellent point. I really apologize for this. Okay. Somehow, yeah. I hope now it should work. Yeah, great. So, okay. Exactly. So I was there mentioning exactly this was the figure which nobody could have seen before. So yeah, as I was telling, the train transportation could be the way of future commuting, but there is a serious issue in the whole train transportation, and it is one topic is the capacity currently. So like especially in Europe, the train stacks are overwhelmed because it's used also for the passenger or also for the cargo topics. So one solution would be to build up new tracks, but that's an issue as there is it would take a long time, and also there is not enough place in urban areas. Second topic is reliability. I don't know how many listeners are here from Germany, but every time when I go to a train station and I hear Deutsche Bahn, that there is a delay. So it's quite often. And one of the main reasons for the delay is the state of the tracks. So like 60% of the delays, or 40, I guess, is caused especially due to the problems in the track, because the tracks needs to be maintained, and especially switches, which is a big topic. So all this topic also boils down to the costs. So And our company targets all these topics, and what we would like to help of the railway industry to understand how their tracks needs to be maintained. And here comes in the point of one of our devices I would like to talk about today, where I am doing together with my team the firmware verification and validation. So to put it to a context, this is one of the embedded devices we offer, which is mounted on the track, and this is measuring the displacement. So when a train goes through this device, then actually it's monitoring like vibrations, we could say in a simple words. So there is a sensor, and this displacement is then transmitted to the backend, where is an AI analyzing it, and based on this displacement data, you can give a lot of insights, like how is the track bed health, how is the switch health, what kind of trains are going through this track, how is the load of the track. So many important aspects. And yeah, this small yellow box is running a firmware, and this firmware is developed by our team. And yeah, it needs to be tested. To get more understanding of the problem of the testing topic, let me show you a short video. You can see here this red dot. I think you can see you can see my mouse. So this is the device put to the track. And now you will see as the train goes through it, it's an ICE. It will be slowed down, and down there you see the real-time data. So, and you can please look at here down, you see how the track moves. This is an issue, because if there is such a huge movement in the displacement, the track and the switch degrades very fast. That means it needs a maintenance. So actually those stones which you can see lying around should be grabbed and then put it under the train track. Putting it to a very simple words, I think our marketing guys could tell it with a much more railway jargon. But the main point is that this helps to monitor and say how the track status is, and which is more important, it can also predict in the future when something will go wrong. And if something goes wrong, then before it goes wrong, you can go out, you can maintain the track, you can make sure that everything is okay, and then we travelers, we are happy because the trains are on time. So this is now, I cannot have live questions at the same time, but try to guess what is causing me sleepless nights, like other than my 3 small kids. One big thing is that if we mess up testing, if we mess up the validation of this firmware, then we have dead devices in the field. So imagine that there are thousands and thousands of switches all over the world on the train tracks, and we install these devices, and these devices are being updated. Every time we bring out a new software, a new feature, we adjust something, then this device needs to be flashed over the air. And yeah, if we mess up software testing, if we don't catch a bug, these devices can be just bricked, and they are not capable to communicate. That means you have to go to the field. But getting a train access, track access is really difficult. I was there like 3 weeks ago, and trains going there with 300 kilometers per hour. It's really not a joke. And like if every device on the track would be bricked, this would have serious consequences. That means it could mean that our company can close its doors and find some different job. So this is a serious topic. And to show that how we really make this to avoid that this happens, I would like to give you some insights how we test our firmware, give you some tricks that then perhaps you can also use it for your own testing thing. So this is my fellow colleague, Jonathan, and I would like to show you just the ordinary day how we work with the firmware testing. So I don't know if you can listen to the sound, but this is like a... So you could think of that I made it as a joke, this video, but actually this is quite serious. What Jonathan is doing here actually is testing the acceleration sensor, and there is we had to test the feature that the firmware is capable to seeing the maximum threshold of this sensor, and one easy kind of manual smoke test, semi-manual smoke test was hitting the device with the hammer. But I will get back to this. So there is just one way how to test the device, but we have many different safety nets, or we call it quality gates. This quality gates ensures that at the end, the firmware that is being flashed on the device will be stable and does not contain some critical bugs. So few things. I think most of you know code review, classical thing. Anytime we change something in the code, we create a pull request, and if there is a person, another person looks at the code. Then we have static code analysis. Our code we develop in C++, so there are a lot of things that can go wrong, and the static code analysis or a linter holds your hand, shows you if there are some dangerous ways. For instance, if you are using, if you forget parentheses in defines or similar, also showing the cyclic complexity. So generally, you get a smell of the code based on these results. Then we have automated testing. I will go deeper to this topic in the following parts of my presentation. And there is this semi-manual test, which you could have seen Jonathan one piece of it. Of course, we use continuous integration, which I guess for you guys, most of you who work with web development, application development, it's not a topic like it's state-of-the-art thingy. In the hardware development, I think this is still not the standard. So as I mentioned, we create unit test, review analysis on the pull request. Then we need to build a software because we have a cross compiler. So you have to be developed on Intel processors, but we deploy on some different architecture processor. So we have to build a binary, which is then being flashed to the device, and then it's deployed on the device and it's being tested. And I think this thing is something which is not that standard in the embedded world, because mostly what I have seen, the testing happens at the end of the development. So usually in automotive or different embedded testing, there is a waterfall model or a V model where you develop, test with unit test. At the end, there is big hardware testing. So we try to do it during the development. And let me give you some to show how really we do this. And here we come to the automated testing. So we do not only need a hammer, but we also have some other cool stuff to make sure that, that the firmware is tested. I would say the biggest challenge of an embedded testing is not writing the test, but to make sure that the infrastructure works. Like, imagine this device I had it. So let's say I want to test if the MEMS sensors is working. I want to test if the data I have sampled is correctly transmitted through the GSM network, through mobile network. Let's say there is a bad connection to the mobile network. Then I want to check that the GPS position is correct. What if I don't have enough satellites? What if the firmware gets in a never-ending loop? So all these things, I want to create a test case for this, but I need to build up this thing. I need to set up infrastructure. I need to simulate somehow the trains. So like there was a plan that we bring up trains in our office, but my boss said that our office is a little bit too small. So no, jokes aside, really. So you cannot really test with a train. So you have to simulate somehow the train. Then there is a problem with the GPS. In-house, you don't have GPS signal. And all these topics, it's actually the most effort creating all this infrastructure, which is not only done once, but you have to maintain it. You have to make sure that all these things works stable, and just then you can think about the test, writing tests. So it's writing test, I would say, is the last 20%. It's piece of cake. Once you have the infrastructure done, writing test is really nothing special. So, and for this, we have the testbed hardware infrastructure. So how do we do it at Konux? We use Raspberry Pis, and these Raspberry Pis are connected to our device and some additional hardware I will show. If you build up a testbed hardware infrastructure from scratch, my lessons learned from the last 10 years where I was working with this, you have to ensure that you need a scalable infrastructure. What does it mean? I mean, if you buy some super complex mega LabVIEW-based computers and you have like 2 of them and you want to include in the continuous integration, so imagine you have 10 developers push PR every hour, and now you have just 2 test beds. That's a complete no-go. And for this reason, whenever you build up hardware infrastructure for testing with continuous integration, make sure that the test beds are as simple as possible, that you can replicate it quite fast, and that they are reliable. Like for instance, what I learned for years, I'm a huge USB port hater. They are everything just not reliable, just as an example. Also, you have to ensure like our test beds are reachable remotely. This helped us to get through Corona. Like every other developer was working from home office, but the testing had to happen. So we could connect through the network and do our job. Then, of course, you replicate the test beds, but not every test bed has to be the same hardware. You need different features, as I mentioned. For instance, GSM communication, where you could use a GSM attenuator to simulate various bad connections, or you can have specific sensors on some devices which are not available in other. So you could have test beds with features, and then you can tag these test beds and said, okay, this test bed has this functionality, the other test bed has other functionality. So it doesn't mean that if you have test beds, they all have to be the same type. And one key point which you have to do is, before you start your test, you actually have to verify your own test bed if it's working, if all the cables are connected, if it's stable. Because it's nothing worse than if you are running a test that takes 3-4 hours and you come back and you realize that the test is red, but not red because you have found a software bug, but because USB communication stopped working or similar. So this is an example of a Konux testbed. We have a Raspberry Pi. We have our device here, as you can see. And then we have a so-called interface board. I will talk about this later. And then we have a small USB switch where we can activate, deactivate USBs, and the programmer. So it's relatively simple. Then we have a small motor, and there are parts which are not shown in this picture, which make sure that the testbed is waking up based on acceleration. And this interface board ensures that we inject defined signals. So as I mentioned, we couldn't get a train in the office, but what we can do is inject a specific test signal on some AD converter, which you can then sample, and then you have a defined signal that you can evaluate on this. So this is from the hardware point of view, but we have also the whole software topic. So as most of other people, we also use Jenkins for continuous integration, where we have all these test beds embedded as agents, and they are communicating through SSH. At the same time, as I mentioned, Konux is not a hardware company. I forgot to mention at the beginning, we are offering software as a service. So really, this hardware is just a small piece of the puzzle. And that means there is a huge backend infrastructure with the whole AI, data processing, doing the whole magic. And this, you cannot leave it out when you do the test, the embedded software testing. You also need the backend. And of course, it's not really healthy pushing data, like test data, to the production environment. So we have a sandboxing which we control Jenkins with Spinnaker and create a copy of the whole sandbox. And with this help, we can really inject various data. The reservation of the test beds are done through Jenkins. It's a simple idea. Like when there is an automated job running, then you can then it's reserves a test bed, or if somebody is working on the test bed, then he can also press a reservation. And one big topic was at the beginning. At the beginning, we had like 3 test beds. It was not a problem installing 3 times Raspberry Pi, but when you have 12 or 10 and more, and you need to update packages, you definitely need a provisioning system. We took Ansible. So there is also a topic that you get your test environment up to date, that you have actual packages. And it's also a topic from the security point of view, as we are also having some communication to the cloud. So as a next step, I would like to show you what kind of automated test we are using and how to make the whole picture of testing. So unit test, I don't know if I have talked about a lot about this, because this is a unit test. It's running on a simulated environment. So it's like all other developers create unit tests. We have code coverage. We test the functionality, mock the stuff away, and we focus on modules. So it's just a classical stuff. There is no difference in like in any other software development. Then we have the smoke tests. What is a smoke test? So you create your pull request. The developer creates its pull request. He got the code review. He got some unit tests. Everything is compiled. Now we have a binary, and this binary can be flashed on the device. And even a smoke test is the flashing. Did the flashing goes right? Is the update working? Does the device boot up? Do I get some logs? Do I get a never-ending reset? So it's crucial to run this smoke test. Why do we call it smoke? So first, if you do something wrong, then really wrong, then the device can smoke. But on the other side, also, it needs to be fast. You have to get a response in 10 minutes. So my fellow backend testing colleagues asked, like, what? Your tests are taking time? I mean, yes, in embedded, everything takes time. I mean, just turn on some sensor, deploy stuff. It just takes time. So flashing things, formatting like a eMMC, it takes time. So that's why you choose crucial tests that says if the device is alive after this change was introduced. So it shouldn't take more than 10 minutes if you have a smoke test. Another topic is the integration test. So usually embedded software, now I really reduced the complexity. It consists of some applications, some kind of middleware magic, which could be some operating systems, some interrupt handling routines, and then down there are the drivers that are responsible for communicating with the interfaces on the hardware. And the problem is that usually if you have an application, you cannot really test the drivers. And the drivers are crucial stuff. I mean, you want to make sure that you can communicate with your file system where you put your data. You want to make sure that the GPS is working, like how is the GSM connection and all this stuff. So, but to do this through the application is difficult. So what you do is you cut away the application, put there some transparent communication through UART, and then you can access really drivers and low-level stuff. And then you can do crazy stuff like checking the MEMS calibration. You can see if you can find like GSM communication towers in the nearby and such stuff. So it's called integration test. And usually you need an integration board, a specific PCB, which accesses test points. Then we have the mock test. We introduced it recently. That, as I told you, we have the sandbox, the backend sandbox, the whole REST API where we communicate with the system, where we fetch updates, send data, and so on and so on. But what we had a difficulty is we couldn't test negative scenarios, or you had to introduce some testing APIs for the REST interface, which was complicated. So based on this mock server, we introduced our own fake API for the backend. And there we can do crazy stuff, failure injection, some errors in the HTTP certificates, and so on and so on. So this makes sure that we also test not only the good, but also the bad scenarios. Then there is a very specific DUT test, which is really just for embedded. This means device under test. As we also produce these devices, we have a hardware manufacturing topic. And when a device is being produced, you need to verify that the whole hardware is okay. And whenever you introduce a change in the firmware and you go to the production and the production stops because of this change, yeah, that's bad. Like a production line that it's stopped is costing a huge amount of money. So you really want to make sure that whatever change you do, it does not affect the whole production testing. And at the end, it's a system that's it's nothing special. It's more combinational, all of these test types I was mentioning, where you can combine these techniques and test a whole complex scenario and make sure that it works. How is this being done? So we are using Python and PyTest, but this is really just the underlying layer. And as every embedded company I was seeing, we developed our own testing framework, which is based on the PyTest. We have this whole controlling of the Raspberry Pi, of the GPIOs, the whole backend communication. So whenever you work with embedded, I really tried in former companies to take off-the-shelf products. For instance, LabVIEW. I had in automotive some experience with LabVIEW, which just did not scale and did not work. So it did all these out-of-the-box tools usually for embedded have some limitations. I mean, especially it depends what kind of test you are doing, but we decided here also to take our own development, and it gives us freedom. So now that we have all this information, I can show you our release pipeline. So as I mentioned, the developer creates a pull request, runs a static code analysis, unit test, integration changes, and then a merge happens. When the merge happens, we have the master branch, where again the unit tests are running with all these changes together. Again, the integration happens, then the integration test, DUT tests are running. And then, which is also specific for embedded, we run nightly tests. Now you can ask why. And this is the reason I mentioned some of the tests takes like 6 to 8 hours. For instance, example, I don't know, we need to test the file system. You want to format the file system. You want to fill up the file system till the end. You would like to send data and cut data in the middle of the communication. You would like to make a GPS connection, but ensure that you don't have a good GPS signal. You want to make a different kind of wake-up scenario, or a different kind of communication troubles. And to every time you run this, you also need flash to the device, and it just takes time. So this is the reason we have nightly test. And this is like our daily process. So all this thing happens automatically, except the code review and the merge topic. It's a manual topic. And so in the morning, when our team comes to the office, just looks at the dashboard and sees, oh, these tests are red. And then we have to analyze, is it a real bug? Is it a test infrastructure topic, or what have we seen? And then, of course, once all the features are implemented, we have a release candidate. We do all the same magic, and then we run alpha tests. Again, what's the difference between alpha and nightly test? Alpha test is even a bigger test scenario, and alpha test days runs for days. And they are like, for instance, you want to flash different versions of the firmware because you have an upgrade path, downgrade path. You want to combine different configurations. So there are a lot of different combinations. It just takes time. So we don't run it daily. Actually, the alphas are also running once a week just to make sure that the whole infrastructure is up and running. And at the end, that release candidate, I forgot to mention, of course, you are running also the semi-manual test I will show you. And at the end of the day, you have a release. So let me talk about a little bit about manual test. There are kind of tests which just to automate takes either too much time or it's too much effort. So for instance, again, as I mentioned, you cannot get a train in the office. We have a huge shaker, which is my I love and hate this toy at the same time. So it's really cool stuff. It can really apply huge forces. So if I run the video and look closely, we can simulate the train wheels, and at the same time, I can really get a real at least a signal that looks similar to the one that's happening in the field. Another topic is sometimes you need to use a climatic chamber because in the field you have temperature differences, and we had like issues, I don't know, watchdog kicking in based on temperature or some problems happening. So these things simply you have to assist. Or one of the example with the hammer, which is just the easiest to test a threshold or calibration topics. One very good also thing which I forgot to mention is the pre-rollout. That means when all the tests are through, I forgot to mention this here, the release process. When all the tests are done, we flash only few devices in the field. With this minimizing the risk that something we have overlooked. And there were bugs, or recently just one bug, which was really we could have find it only in the field. So if these two devices are okay, or we see that they are not okay, then we can still return to the release process and try to fix bugs. So let me tell you something about the test management. Although most of the stuff are running automatically, still you have to manage the whole process. So the bugs are being found in every part of the process. These are real examples from the last year. like I said, oh, there's this calibration where you have to turn around the device because you have to calibrate the MEM sensors. And it's really, like I said, do we really have to do it? One colleague asked me, and I said, yeah, although it's a repetitive task to every release, so we do it 4 times a year, we really found a hard fault error that was not really possible to find with automated tests. Or we had a GSM disconnect issue, which was really possible to find in the circumstances in the field, and that was found in the pre-rollout phase. Or just a code review showed that we have a stack setup issue. So I think all of these steps are really important, and unfortunately, you cannot just rely on automated tests, but most of the test needs to be automated so that you have a continuous integration. How do we do the whole thingy, like collecting logs, planning, and all these things? So we have Jira for the test planning. Then in Jenkins, we have an Allure plugin showing test results. Artifactory, we store logs, and then we have the whole manual test results and documentation in Confluence, and the automatic code, automatic tests documentation is in the source code. And every time I need to compile a report, it takes me like a week or 2 getting all this data together, plan this, check this, like typical thing. The alpha tests, some of them fails due to test infrastructure problem. Then I have to rerun the whole test, the whole alpha test, because I need a nice green report, because I know that those reds are not bug. And this is where fellow colleagues TestGear came in place. And it's really not now an advertisement place, but I'm honestly telling this because this was the way how I figured out about TestGear and some other products. And we are just starting to integrate it in our environment. And I really hope to get rid of all of these steps and save at least 1-2 weeks. By the way, that we directly push the results from Jenkins to TestGear directly from the test beds, and then I can generate a report with one click, also do all this test planning and collect the logs and all the stuff there. To the end, I wanted to summarize perhaps why is embedded testing so hard? So one of the difficulties, tests are taking long. You cannot do anything about this. And then as an embedded tester, you have quite a lot of tasks. So you have to come up with the idea how to test. That's not enough. You have to write the test as all other people are writing tests. But then you have to create the infrastructure so that you can execute this test. And then you have to program the testing framework. Then you have to fight flaky tests. And it's not only flaky because of the implementation. Most of the time, the flakiness comes from the whole hardware. And did I mention that I love USB and hate? Yeah. And of course, you need to analyze daily the test results. And the hardware sometimes just breaks, like completely. Like you have, I don't know, this week I was debugging a problem, and it turned out that one MOSFET burned on the integration board, and it took us half a day to fix this. So on one side, it's hard. On the other side, it's a really cool job. So if anybody considering changing to embedded testing, I can really recommend, because you do so many different stuff. But so actually 2 of us in our teams are testers, but this works greatly because the developers itself in our team, they are even helping us and working with us on the testing topic. At the end, when I find a bug, I come to the developer and I say, hey, this is a bug. Can you do something about this? And it's the brave developer who sits down and fixes the problem and verifies it. And I'm so lucky at Konux because all the developers in our team, they just work with. They sit down, they go to the test benches, they verify their implementation. And when there is a bug, we sit down together, we try to debug, we take oscilloscope. So it's really awesome. So I wish in every company developer would be so test affine as in Konux. And that's why I wanted to thank for our whole team. Like we, of course, everybody has some special skills. So there are people who write C++ code. There are people who work with mechanics, or there are people who are product managers, or electricians. But the whole team works together, and testing is not just the topic of my colleague and me. So we are like two of us and some students, but it's really the team who works together and ensures that we have a quality device. Because as mentioned, if something goes wrong in the field, the whole company can crash. So that was it from my side. I hope that you could listen and that it was a little informative for you how embedded testing is being done. So if you have any questions, I would be happily answer them.
Thank you very much, Attila. We have approximately 6 minutes left for questions. So if you have any questions for Attila, please share them in the chat. We will be able to ask him. In the meantime, I actually have one question for you. Which tests would you call hard to automate? And do you have a way to reach 100% test automation in your case?
So if I understood, so which test is hard to automate, you meant?
Yeah.
So mostly there are specific timing tests are usually hard. For instance, a startup time. It's a very crucial if a train comes that the sensor wakes up before the train arrives. And this you need an oscilloscope or some logic analyzer, and all these things is doable, but it's a lot of effort to implement it. So you have to find a way, like if it's worth of it. Mm-hmm. So that's why I think you can reach 100% test automation for sure. But in that case, means you really need to invest a lot of time. And the question is if it's worth, or you say, okay, 4 times a year, I sit down, I take that oscilloscope, plug it in, and test it. So, yeah.
Thank you. Let me check the chat. Okay, we got one question. If the product is very custom for every customer, what is the best way to run automations?
What we did in the past is we created virtual test benches. That means, for instance, we created virtuality with Proxmox, or you can use a VMware. They were like virtual softwares. You can configure it for the customer. And then based of USB or device passing in through virtual devices to real hardware devices, you can manage then different configurations. It's not easy, but it's doable. And once you have it up and running, then you can test various devices at the same time.
Okay, great. We have a question from Michael. So in semi-automatic tests, can you give some example of steps you automate and what the interface to the testers looks like?
Mm-hmm. For instance, this hammer you have seen with Jonathan. So we have a UART communication. So it's like a console. So we work with scripts. So we don't have a UI. Although I was thinking about this, but it's just too much effort. And through this UI, you have like step by step. You say, okay, hit the hammer. At the same time, we are monitoring the UART logs. So it's just the logs like every other software. So you're monitoring the logs. You are capturing with regex the thing you are awaiting, and then you say true or not. So mostly they are scripts, and they guide you through the process. And at the same time, at the background, for instance, we can also generate train traces and say, okay, now connect the oscilloscope. Look at this, take a picture, so like that even a monkey could theoretically do it.
Okay. We have a question from one of our speakers, Christophe, actually, is asking, do you involve model-based system engineering?
To be honest, not really. So in the past, I tried it right. I tried with UML2 and model-based design of all of these systems. It was just somehow either I was not able to use it correctly, or it was a difficulty for the team. So I can remember I was on Embedded World, and there was Douglas Powell showed us an embedded design of a pacemaker based on model-based design, and I was like thrilled, like how to use the whole activity diagrams, everything. So at the moment when he showed it, I said, "Wow, this is cool stuff." Then I went home to the company and I tried to apply it, and it was not working. And the major issue with the whole model-based design was in embedded that you cannot really debug. Or the other thing which I take from the automotive industry, I was working at the OEM where we were generating code for the cars. And after 4 years, we were writing Python scripts to analyze the generated code bugs. And then we asked why. So then we just went back to C++.
Fair enough. Okay, we have 2 minutes left. Is there any more questions? Let me check. We have one question left. Is there any specific way you treat performance or load testing for embedded software?
Performance from which point of view? Like the embedded system performance?
Mm-hmm.
Yeah, we have a tracer. So it's it's kind of debugger where you put in specific hooks to the program, and when it's executed, then this tracer can show you the speed of the application, like the performance, like how fast you get interrupts and stuff. I have to admit that currently we are fighting with this because we have some issues with the connections that you really have to have a fast connection, and yet the tests are still to be done. But this is the way to do this.
Okay, cool. Thank you. Okay, that's the end of the conference, I guess. Thank you very much for your time, Attila. Thank you for joining us, and see you next time.
Thank you that I could be there. Thanks.
So Archie is going to introduce the next conference, and I will be back in 1 hour.
Yeah, great. Thanks, Attila. It was great to see you. Now the next person would be Christophe. Christophe, hello.
Hey guys, how you doing?
Yeah. So welcome, Christophe, and thank you for being with us today. Your conference is about flaky tests in an agile context.
Yes.
And lean practices in test automation.
Exactly. So I think that
sure we can see everything.
Yes. Can you see my screen? Can you see my presentation?
Yes, everything is on screen.
Okay, great.
The mic is yours. Fire away.
Thank you, Archie. In the previous talk, we had Attila that dealt with Flaky tests. So this is a very good transition for this presentation. We'll see all together how to handle those Flaky tests and hopefully provide you with some ideas, inspirations. Okay. First things first, let's figure out how it would look in a regular plant. I mean, let's figure out an assembly line. Okay, in this assembly line, you can see several assembly benches with several workers. And at some point, there is one of those workers who is experiencing an incident. Okay, this usually triggers some alert. The term that we find in the lean management world, basically used in those plants, is and done. We'll see that word within a couple of seconds. Therefore, afterwards, you will have some analysis phase, and once this analysis phase has provided some outcome, well, fixes and improvements are introduced into the assembly bench. Well, I mean, fixes, improvement. It could be some, I don't know, some improvement about the assembly lane, or improvement about processes, or even some training regarding these poor workers that experiences some issues. Okay. I dealt with andon. Andon is actually a Japanese term. You may know that lean management was created back in the 1950s by Toyota. So basically this happens in plants, and all of those terms are in Japanese. So sorry for that. but you will learn some Japanese in between. How does it look like in a plant? There is a sign everywhere in the plant, and whenever there are some alerts that are raised, some end-on, this lantern just lights up, and everyone or people that would feel concerned or that are free for that would rush to the place where the issue to help the guy fixing the issues. In a regular Agile team, actually we have different kinds of end-ons. Actually, at dev team level, we also have we have these ceremonies such as the daily Scrum meeting. The daily Scrum meeting is actually a very good place to trigger alerts on the sprint objectives. The aim of the daily Scrum meeting is not throwing a ball to your neighbor. Okay, this is basically raising some alerts about will the team be able to reach the objective, the sprint objective, or are those objectives endangered by some risk or by some event that occurred in between? You also have an opportunity to raise such a lantern in retrospectives. During those moments, of course, since you think about what happened during the sprint, well, you will say, okay, I've noticed that we had such an incident and we should introduce something to fix that in order to avoid this issue reoccurring again, okay? Well, actually, you have, of course, those ceremonies, but it's not only the proper place to raise an alert. Anytime, anyone from the team can raise an alert, raise the hand and ask for having some help from whoever, just like this end-on mechanism occurs in a lean management and in plants. The other place where you can find some end-on is in the delivery pipeline. We had a quick demonstration regarding this with Attila, but well, you cannot see the Jenkins or the Bamboo, whatever the name of the orchestrator, but everyone has experienced that a given stage or step, whatever the name, came to red because actually your pipeline was broken. And it means that, well, this should be fixed because the pipeline should be made available anytime to anyone. And of course, again, if there is an issue, well, it should be fixed as soon as possible. And I've seen some companies that even raise the bar of this maturity level by providing a time box. If the fix of this pipeline exceeds the time box, then the work is reverted. Place at which you can see some end-on mechanism. This is inside the product. This monitoring can be done through logs, and of course those logs would be monitored, or even some automated or not automated issues inserted in the backlog, because, well, some events are not that severe to be raised and to be escalated to everyone at once, but some others do require some immediate actions. For instance, you can have your server that would send you mobile text to tell you that there is no power supply left, and you have 1 hour because of the batteries embedded in your system to let you do something, eventually stop the system or whatever. Okay, so this is the end on. Now let's get back to our plant, and now let's imagine that instead of having some workers, you have some robots. Of course, robots will face weird situations. Well, when it comes to human being, they can adapt their process and they can use their intelligence to face new unexpected situations. But when it comes to robots, well, what may happen is that if they raise an alert for silly situations that were not taken into account beforehand, well, the line operator will then be overwhelmed by alerts and he won't be able to tackle things at once. Therefore, Lean has introduced a practice, paradigm, whatever the pronunciation, sorry, that goes like, okay, we have to make those robots kind of not intelligent with some AI stuff, but some, I should say, some ways to handle unexpected or previously met situations. This is named Jidoka. Jidoka is not about some judo practitioner. This is actually a portmanteau word. It is composed with autonomy and automation. Therefore, we can translate Jidoka with automation, okay? The aim of Jidoka is actually making defect-free processes by continually strengthening process capability, continuous improvement, and feedback. The aim of Jidoka is actually to, whenever there is a new situation that is some kind of bug for the robot, the line operator would lead on this new situation and try to upgrade the behavior of the robot. This new feature, this kind of upgrade, will be based on detecting new situations or previous known situations from previous hand-ons. And then once those situations are known, the robot will try to handle them. It means that actually Jidoka is used to upgrade robots with incident and with some self-fixing features, okay? The thing is, if we come back to our pipeline gifted with automated tests, as said Attila, we have, Flaky tests. It means false positives. There was a survey done by a guy named Ingo Philipp. This guy revealed that most of the time, according to him, 72% of the time, those issues were false positives, okay, against only 27% of the time due to genuine bugs. Of course, what we have like false positive is basically script issues, data issues, and environment issues. So once this is said, let's get back to our pipeline. Say my scripts are kind of rock solid with a reliable rate that reached something like 99.7%, which seems fairly high. Unfortunately, if my pipeline holds 400 test cases that are automated, if you do the math, you will realize that your overall pipeline reliability will be something like 30%. 30%. So it means that, whenever you launch your pipeline, 70% of the time, it will fail, it will break. And if you do apply the rate that Ingo Philipp has found before, it means that half of the time, those failures will be due to false positive. It means that half of the time, human interaction will be required not to add value on the product code, but just for fixing issues in the pipeline and in your tests. Now, if you realize that 400 test cases is not enough, let's raise the bar with 700 test cases. Now the situation becomes really dramatic because 700 test cases in your pipeline will lower your results to 12% of reliability. It means that 63% of the time it will be due to false positive. Being said, let's imagine that the whole team is sharing this concern and try to find the proper way to improve your test scenarios, code, environment, and data and everything. That is to say, they would tackle those false positives and they will reach 99.9%. And if we still use those 700 test cases, it will mean that developers, the team, will be bothered for false positive only with 36%. It means that by adding those 0.2%, your pipeline will be improved from 63% to 36%. It really means that, well, reliability improvement of your test cases, automated, hopefully, is a major thing. This is key. You cannot do without. Now, let's try to imagine how to improve those test cases, those script scenarios. By thinking about this, I found 4 kinds of Jidoka maneuvers that could be brought to your test cases. The first one is, well, the most well-known one. This is a retry-based Jidoka. Most of the time, those retry-based stuff is brought by brutal replay. I mean, this is just, okay, nothing happens, I try again. Nothing happened, I try again, and again, and again. And after a while, I say, okay, it won't work. This dumbest approach of testing is not what would actually a tester would do. Because this guy, just imagine that you have a professional tester. After trying 1 or 2 times this retry, don't retry, he'll try something else. He will try to find, well, why is it failing? And eventually, he will also try to find some workaround in order to achieve the test objective. Why do I speak here about test objective? Because just imagine that you have an automated test and it fails because of something that went wrong. But unfortunately, if the test revealed to be not okay, if the test appears to be failing because of something, some glitch in between that has no relationship with your objective, well, unfortunately, regarding your KPIs, you will see that this requirement, the requirement covered by your test cases are failing, which is not true. It may be something that should be worked around in order to find yet another solution to reach your objective. If you only stick to this brutal replay, it will actually cost you a lot of time, a lot of resources by retrying things. Moreover, if you hinge your test strategy, Jidoka test strategy, only on this brutal replay, it will only prevent some lagging systems. Okay, it means that, okay, the widget on my web page is not appearing. Okay, so I try again, and I hopefully expect that it will appear one day. But well, is it what we want to have? Actually, this kind of situation just reflects how little we can test the invoked part. I mean, just imagine that you have some button that does not appear on your interface. Well, just try to ping the underneath server. If there is a database underneath, well, is the database alive? Of course, if the database is not alive, you will quickly conclude that, okay, we have an environment issue. And therefore, you can say that this is a Flaky test. This is a false positive because the environment was not okay. And this will lead, actually, the monitoring of testing quite fast because, okay, I have a Flaky test here. I don't have to do some step-by-step monitoring of this test to find that the database was not responding. Moreover, if you use only this brutal replay as a Jidoka strategy, well, it will just say that your scripts are not reliable because one day it passes because the environment was okay, and the next day it won't. And how can you handle this undeterministic result? You cannot. Okay. Basically, you should aim a solid set of test cases and scripts. So the proper way to handle those retry is basically to generate suspicion, and it should draw your attention to say, okay, I have this kind of situation that occurs on a regular basis on this test. What can I do to avoid this? So keep in mind that as a conclusion for this slide, not these slides because there will be some other conclusion, but well, your tester should do your script should do some deeper tests and try to find some workaround, okay? Doing some deeper tests infers testability. Testability has actually 4 sides. The first side, which is the most obvious side, is the so-called extrinsic testability. This is the visible part of the product. It means, okay, what's happening at the GUI level? Okay, my button is red, so nothing works. Well, it doesn't work. The button is green. Okay, I have immediate feedback from the user interface. But if you dig into the technical layers, you will see that you may reach some technical testability because you can have a look on the logs, or you can even query those underlying APIs and components that are underneath, okay? Should it be private or should it be public? But well, pinging a server is something that anyone can do, at least you as a tester or you as a scripter. You could ping your server, you could try something else, you could look underneath to see if everything is, if there is an issue between this component and my UI. This leads to so-called intrinsic testability. But unfortunately, all of this is not enough. You should rely on this social testability. What is that? Say I have a developer in my team or in another team that has developed something that enables some testing of his component, but you don't know about that. If you don't know how to test that, it's not testable. Therefore, if you don't take into account the social side of testability, you could not test things. You cannot go deeper in test and try to see if there is actually an issue in the environment or something else. And social testability can be covered by processes. Okay, there is somewhere a document that tells how to test that. It means that actually there are some knowledge management about this testability matters and means. And above all, it means that you should have some communications between teams and inside your teams to make sure that, okay, there are things available for testing matters. From those 2 previous JIDOKA types, we have something else which becomes obvious regarding those Flaky tests. This is basically KPI. Okay, a KPI is not JIDOKA itself. This is basically an enabler JIDOKA. Actually, if you take into account the warnings from suspicious scripts, you will see that from the amount of failures, should be false positives or genuine bugs on each script, you can have a guess on, okay, is the result of this script a false positive or is it a genuine bug? Say you have a given script that always fails, but because you have tracked that, because you logged that somewhere, this is always due to false positive. Then you can pretend, you can imagine, you can figure out that now if this script fails, this is certainly some false positive. On the other side, if the same script reveals anytime some bugs, well, you can also imagine that this time this will be a genuine bug. Of course, it does not prevent you from having some investigation on that, but it still provides you a clue on that. The other kind of warning that can be used as a is the script stability. I mean, again, if your script always experiences false positive, then you can know that you can say that your script is not stable enough. Of course, in the very same situation, if your script is brand new, well, you can guess that it is not as rock solid as some others. Therefore, if you know how old your script is, you can guess that it may be dodgy, the result may be fuzzy, and you should analyze that. Moreover, in the previous Jidoka, I shared with you about workarounds. It means that your script will be gifted with some new situation handling and will try some alternate path in the scenario. Of course, the more alternate path your script involves in the running of its process, the more dodgy could be the result, okay? Doesn't mean that actually those KPIs are not rock solid. This is just to give you a hint in order to focus on the most reliable script, in order to say, okay, it's good or not. And eventually try to also address the most fragile scripts that you have in order to tackle them. And last but not least, regarding this, it will also provide you with a health status on the script reliability in order to have a clue on how solid is your pipeline. The last the last Jidoka that I would like to introduce to you is Pokayoke. Yet another Japanese word, I'm sorry for that. Pokayoke means mistake proof. At the beginning, they called that, well, the guy who invented that, his name Shingo something, okay, whatever the name of this Japanese guy. He used to nickname that Bakayoke. Baka in Japanese means idiot. So in the mindset of Pokayoke, because he realized that Baka was not quite interesting for the workers because they were the idiots, okay? But he tried to insert in the assembly line some kind of devices that was mistake-proof. Just think about a USB plug. You can plug a USB key only in one sense. You cannot revert that because if you would, well, on your key. Therefore, your USB key is gifted with this mistake-proof engineering stuff. In an agile team, Pokayoke can be introduced at ideation time. With design matters, okay? Design can just prevent silly things to happen. You can think about some very intelligent or very smart compilers that do prevent some things that are not permitted. I remember once I learned Java back in 1997. Yes, sorry. Java was banning things that were not complying with these naming conventions. Okay, we find the same thing on with Python, with this PEP 8 stuff that say, okay, this is not ideal, and you have linters that kind of prevent you from delivering things that are not compliant with what they say. So designing is great to introduce some Pokayoke stuff. Just think about if you have some, I don't know, some microservices. Of course, you will see that, well, those microservices, especially if you introduce immutable services, well, you will have different versions that will exist in parallel. And unfortunately, you try to plug to the wrong microservice. If by design, you have to tell, okay, I intend to use the version 5.7 of a microservice, but this microservice say, okay, no, I'm version 1.3. And because of this protocol, you will just spare your time and your life by avoiding using this microservice, and you will try to find another one. So design actually helps Poka-yoke stuff in your everyday life. Still, you can also introduce some Poka-yoke mechanism with end-ons on the product. As said previously, you can introduce some, logs in order to get some analysis, some issues in the backlog, and alerts for immediate actions. Of course, this should be introduced at ideation, because if you don't think about that whenever you do your sprint refinement, well, no one will think about that, okay? So ideation time is great to introduce Poka-yoke. And of course, testing-wise, you can also introduce some test harnesses and mocks just to, try things before they happen on the ground field. Now you can also think about having some Poka-yoke at runtime by detecting and preventing issues in production. Say at some point you have some console, some monitors that provide you some health status about what's happening in production. And you see that the amount of CPU or whatever is raising drastically. So instead of waiting for customers to complain because it does not work any longer, it lags and everything, well, you would just use this monitoring stuff to prevent issues to occur. And therefore, this is a Poka-yoke mechanism. And actually, you can introduce Poka-yoke at any time. For instance, source inspection and retrospectives, okay? Or actually automating anything and everything, including monitoring, could also help you in providing those mistake-proof stuff, because Shingo Shinjeo, the inventor of this approach, of this paradigm, yes, realized that most of the time issues were due to manual actions. So automation is good for that. Of course, reaching this architecture stuff that would eliminate issues is a kind of holy grail. It does not happen like that. You really have to progress toward this by inspecting this, by analyzing stuff. And actually, some authors have provided some progressive Poka-yoke level. The first level is mitigating the issue. Okay, you have a phenomenon, the phenomenon that occurs, and well, you still don't know how to prevent that fully, but you can try to minimize the effect of the mistake. And once you have this kind of situation, you can start detecting the mistake at its source. Of course, this takes time because you will have to investigate and try to find the proper place where the source, the bad, the evil occurs. Once you have this, you can start eventually facilitating the job to your workers, to the guy that would automate or to the guy that would code the production code in order to facilitate this detection matter. Say, for instance, you can ask your developers to introduce some API you could, pick, in order to say, okay, it's still working, okay? Eventually, after a while, you can start replacing the old-fashioned way of work with some new processes that will be more reliable. And finally, you could eliminate this mistake through whatever, okay? Basically, some designing matters and everything, every trick that would be available to you. This being said, if we kind of use a bird view regarding this automation stuff, of course, you have the number that matter, which is scripting. Scripting is not a dumb approach, but you just have to adapt test from your system, and then once you have adapted your test, you can adapt your code. And this is eased by this automation approach, this Jiluka approach on scripts. whenever you have a new failing situation, you would analyze this and try again to adapt your system in order to ease your scripting and make it more robust regarding new situations. But this is not only this. Actually, you may not realize what will happen from only single failures. You may expect to wait a little longer to have more data in order to make connections between those data and realize that actually those situations have a common root cause in order to, again, analyze the situation and try to adapt your scripts. This is actually named a double loop learning. This stuff has been kind of found by someone named Chris Argyris back in 1977. This guy just realized that, okay, if we don't introduce loop learning, what will happen? Say I have a single loop learning based on, okay, I have a user story with some acceptance criteria. Then I do develop my acceptance criteria through, of course, scripts. And the result of those scripts will be, well, pass or fail. What will happen? My script, my acceptance criteria will only tell that my production code complies with what was said by this user story. So this is a compliant product, but is it a good product? To make sure that your product is good, you have to introduce another feedback loop at a higher level. This is what's happening, for instance, with Lean Startup. Lean Startup just starts from an hypothesis, from how the market would react regarding some hypothesis, some new feature. I try to implement that through an MVP, and thereafter I try to have some feedback from the market. This is this higher level direction which is given by this market feedback, okay? This will tell you if your product is good or not good. It's not only a matter of compliance. So, the key takeaway is that actually your Flaky test should lead you to have, of course, solid automated test scripts. But, well, this is easy to say, but how to handle that within a sprint? Okay, this is actually the real nub of the matter. It's not only introducing Jiduka, it's how to do that in the course of your sprint. Jez Humble, in his book Continuous Delivery, says that if it hurts, do it often. It means that, okay, you should not think about Jiduka, well, once in a while. It should be something that should compels you to improve your test scripts anytime. The more often you consolidate your test script in this Jiduka mindset, well, the best your script and the more solid your script will be. So you can do that with double loop learning on script as often as possible with this first stuff that I introduced you with this scripting, Jiduka in retrospective. And of course, in order to tackle those very last percentages, to reach hopefully this 100 reliability, you will require the help of everyone. Again, Attila witnessed on his side that the whole team is participating, and this is actually key to tackle those systemic issues, because at the beginning, you will see that, okay, this is quite easy to tackle a given issue, but after a while, you will have to introduce some discussion with your developers in order to help, well, in order to ask them to help you in order to do some Jiduka by yourself with your scripts. 2, this is something which I find quite relevant in agility. Also, tell me how you test, I will tell you how agile you are. Because, well, agility is not only pushing things quickly into production because it's easy to push shit into production. But, well, you really have to react quite quickly in this direction. And if you want to think about this, well, you have to introduce some tests. And without testing, you will only push crap into production. So how to do this? You have to introduce first end-ons and GDK paradigm. Oh gosh, I forgot about this word. In your sprint refinement, for instance, thanks to these three amigo, or production code and test script practices. Talk could be made available thanks to these sources of inspiration. So if you want to go further, well, buy the books or try to Google them or try to click on the links that are provided here. I guess that TestGear will just provide those slides on the internet. I'm Christophe Moustier. I work here to give you this talk. I wrote 2 books and also promoting this card set, which is underneath this GDK talk, is actually one of those cards which is provided with this QR code. Thank you for listening to me. Is there someone who would like to go for some question or whatever?
Yes, Christophe, there are some questions. Well, the first question would be from Attila. Definitely very engaged and an amazing presentation. I mean, I learned a lot today.
Okay, thank you.
even lost track of time. So the question that Attila asked, did you have a chance to see improvement of hardware-based Flaky using GDK process?
Well, actually, in every plant, this is what they do. You have to understand that this GDK is not an invention of myself. I don't speak Japanese. I tried to learn some Japanese, but, well, I gave up because this is, well, really, really difficult. But actually, in any plant, they practice this on a regular basis. GDK is a pillar. There are 2 pillars in the lean management. And they do apply this GDK stuff. So whenever you would see plants that have robots, they should practice, and they would practice GDK. So I had a chance to visit plants that injected plastics in molds, and, well, I could see that. And my advice is, well, try to have some appointment or some touristic plant, well, some touristic visit in plants to see how they do work and ask them about their GDK practices. Yes, they do.
In a question from myself, basically, just had it in mind. A little bit tricky, maybe. Is it a good or a bad sign when you don't have flaky tests or failed runs at all?
Oh, that question is interesting. Well, the thing is, I've noticed that there is barely no one that provides some indicator on their Flaky tests. For some reason, well, the first reason is that you don't know about that. And there is a saying that goes, as long as you don't know that your bed is hard, you sleep well. So, in my opinion, regarding, well, if I step back to this Ingo Philipp, well, this survey from Ingo Philipp, well, 72% of the time that you have some failures in scripts, well, this is due to Flaky test. And in my opinion, well, I used to work for a company named Amadeus as a contractor, and I was running a team that was automating scripts for them. We had a chance to run something like 3,000 scripts per day, per night, or whatever the time. And the morning was dedicated to script monitoring because there was always failing scripts, okay? And there was always some Flaky test. At that time, I didn't know this GDK approach because I was kind of scaling up in agility and everything. Now I am SPC safe certificate stuff, and therefore I went curious and I discovered a lot of things regarding plants. Of course, I visited plants in between, and it appears that, well, in my opinion, if you just pretend that, well, I don't have any issue, well, you may sleep well, but, well, most of the time, your pipeline will fail because of false positives.
Mm-hmm. So it's an issue in itself that you don't have issues.
Yeah, yes, I think so. Well, you can pretend that your developers or yourself are genius guys. Well, they are brilliant. Everyone is brilliant because otherwise they wouldn't be hired. But unfortunately, well, mankind is made with failures. Sometimes failures could be beneficial for some others, but, well, statistically, we introduce failures. So I think that this is some kind of cognitive bias that's, well, no, I don't have any issue. But do you measure that? Do you make sure that you don't have any? If you don't, well, measuring is controlling. If you don't measure, if you don't have some clues about what's going on underneath, well, maybe this is just like you are boasting, or just pretend it does not exist. This is my opinion.
Mm-hmm. And another question that I had specifically about Pokayoke, or actually Bakayoke, that I liked it a little bit more. So doesn't actually generally replace the quality assurance engineer job?
No. Actually, you have to understand that, well, Pokayoke is also nicknamed as built-in quality, okay? This built-in quality is a way to tackle defects in your stuff. But you have to understand that quality is not only tackled by one approach. You have to combine everything. This is just like relying on unit tests to pretend that you have no issue in your system. Okay, this is not because, well, let me tell you a story. I had the opportunity to visit Singapore. Out there, everything is neat, everything is clean, and well, but you see, there is a metro out there, and this metro is automated, fully automated. There are no conductors. Actually, the code to run this subway was done without testing. It's not that there was, okay, I develop and deliver. No, they actually proved, they demonstrated that the code was working well. There is a method like that. This is called method B. This standard requires the code to be demonstrated thanks to recursive demonstration on loops and everything, okay? So at the end, the code was demonstrated. We have in Paris the same kind of code that was generated for lines 1 and 14. There are no drivers at all. And this little sister in Singapore had the same technology. So everything was bugless. But one day, there was some brilliant guy that took his chewing gum, put that in the RA detector that prevents passengers to be smashed between doors. And of course, well, the train was blocked. Therefore, the line was blocked. Therefore, in Singapore, there are two lines. Well, at the time, there were two lines. The whole subway was blocked. It means that actually the whole country was blocked. Finally, after 4 hours, they found the chewing gum. What did they do? They banned chewing gum selling. So you cannot prevent anything. You cannot demonstrate things. So built-in quality or Pokayoke or Bakayoke or whatever is not enough. This is only a single part that would help things to occur and eventually reduce the amount of shit that may happen.
Mm-hmm. Thank you. Amazing illustration. And thank you for the presentation. There's going to be another one, but before that, we're going to have a little break. Stay with us.
See you later.
And we're going for a small ad break. Let's go like that.
Hi, here is a quick presentation of the Agilitest software to perform automated functional tests. After a quick setup on your computer, you must go to the settings menu to set 3 options. First, the language of the software. Then you have to download ATS using the cloud button. ATS being our scripting language. You also have to download Java with the help of this button, also in the shape of a cloud. Once this is done, we'll be able to create a new project and then create a new test. To create a new project, you have to click on the button at the top left of the new project. I've already done this, and we can see here in the Project Explorer the tree structure of an existing project. I will open a scenario of test automation here, which is already implemented. We can see that this scenario begins by starting a channel, the channel being what we're going to automate. Here we are able to set up the automation either of a browser with a web application or an Android application, iOS mobile application, Windows desktop application, or a REST or SOAP web service. Agilitest is able to launch the scenario in step-by-step mode or, of course, in campaign execution mode. Here I have just executed a first action of opening a channel. I continue with the navigation on a URL. Activate a link element at the bottom of the page. I go back to the top of the page. And then I go on with the acquisition of a piece of information that appears on the page to put it in a variable. Here we have the verification that the content has been acquired from the page corresponding to the expected value. And we produce here a summary of a report that will appear in the test report that I will present to you next. This script already existed, but I will show you how to perform an automated action. You need to open the capture tool. The Agilitest capture tools allows to recognize all the elements that make up the page. And if I am interested to an element on the page, I just need to hover it and press on the control key to capture the element that interests me. Here I can check the attributes associated with this element. I can confirm that my working hypothesis on the attributes that allow to recognize the element is correct, thanks to the statistic button. Here we have a green tick, and then I can drag and drop the recognized item to an action. Here, for example, a click action or any other action. Agilitest also supports subscripts. Example, the possibility to launch ATS files inside other ATS files, and potentially these subscripts can consume data files. Agilitest also provides an interface to configure execution suites. Here I will run an execution in a standalone mode, and you can see the summary of the report. At the same time, be aware that Agilitest is also compatible with the CI/CD Jenkins solution. This means that Agilitest is also able to create Jenkins jobs and to execute them. Here we see the test sequence and a specific debugging log that is quite wordy. Here is what a report produced by an ATS test campaign looks like. Here we have the campaign name, at the top right the possibility to download a PDF report. Below we see the name of the script, for instance the name of the scenario, the execution time, the number of actions. And something interesting to notice, we have access to ATSD report, meaning a visual report, which is in fact a screenshot animation associated with caption. And when we make mouse clicks, a mouse appears. When you make keyboard entries, a keyboard appears, etc. in order to make this animation particularly meaningful. Finally, in this report, we have here the possibility to bring back information from the application to the report summaries in order to contextualize the report's outcome. To finish, we can unfold the list of actions with the name of the action, the ATS line, the duration in milliseconds, and finally the return code. Finally, it is pretty easy to switch from the report to the editor by clicking on the number line, and thus Agilitest tells us where to do a potential maintenance. Thank you for listening, and feel free to come to the booth and request a free trial. Bye!
And we're back.
And we're back. So if you just join us, just a quick reminder, so we are live on YouTube and the recording will be sent tomorrow. The next conference, we have Michael. So Michael is going to join us. Hi, Michael.
Hi.
How are you doing?
Yeah, fine.
Good. Perfect. So you're going to talk about how to write tests like Shakespeare. I really like this topic title. And in other words, how to keep your automated tests readable with the screenplay pattern. So
Right.
go ahead, Mika.
Okay. Yeah. Okay. So, welcome everybody. My name is Michael Kutz. And as Emma just said, I wanted to tell you the total not clickbaity title, writing tests like Shakespeare. Yep, and I need to focus right window. Okay. Okay, so first some context about me. You can find me in various social networks. My favorite one is GitHub, which might tell you already that I'm actually a developer, and I turned a quality engineer. And as such, I'm a lot into test automation, and also I'm an internal coach, and I try to get teams to get more comfortable with automation and other practices roughly around software craftsmanship. As I already said, I like to automate things, not only tests. I have a rare brain defect, I think, because I typically am the one who automates and maintains and creates continuous integration pipelines in wherever I am, in my current company and in others. And I'm also fascinated lately by cognitive biases. If you're interested in that, let's have a chat. I have several. So I have a talk about this, and also a nice workshop with my friend Joao that you can check out in May in Cologne at the Agile Testing Open Air. Yeah, and I do a lot of talks and workshops at conferences and talk about all these topics, right? And I'm also a passionate runner, if you're into that. Yeah, me too. Okay, some words about my company. We're Revit Digital. This is a company in Germany, in Cologne. If you're interested in recognize some of these tech icons I put up here, and you're looking for a job in tech, contact me. We might have some jobs available for you. Right. So first, one question also to you. Feel free to answer in the chat. So why should I or shouldn't I structure tests? So one of the most terrible things I think is with tests is when I really don't understand what they are about. So I want to keep my tests readable. This is connected but not the same. I also want to have them maintainable. I'd like to, when I change the system on the test, and that change takes 5 minutes, it shouldn't take 2 days to fix the test that, to adjust the test to that change. It should rather be like 5 minutes for 5 minutes or something like that. I like reusability. I'm a developer. Developers are really lazy, so I'd like to not create something again and again and again and again. So I like to have my test code in a way that I can reuse parts of it when I need to use them, especially complicated ones. I like to have them extendable. Like, I have some tests I need to adjust. I need to write a new one. So it should be really easy to create new tests on top of the ones that I already have. I like to have them changeable, like if any details need to be adjusted or added, that should be easy. I'd like to have the code understandable, not when I execute it, but when I look at it, I'd like to understand what this test is about. I really don't like reading titles and code comments because they tend to lie, especially with test code, because copy pastability is really a thing in test code, especially. And also important and sometimes really not given is debuggability, like what we just saw with the Agilitest suite. I'd like to have some easy ways to dig into, okay, why did this test really fail? And this is also something which Agilitest just demonstrated quite nicely, report verbosity. So I can, for example, click on that line in the report and get into the script. So something like that is really important to me. But there's neither good or bad, but thinking makes it so, to quote Hamlet, Act 2, Scene 2. And yeah, let's look into some code. So this will be a lot about code. If you don't like code, you don't want to see this. So here's the challenge. This is a rather favorite demonstration site of mine. It's automationpractice.com. And this is basically a fake shop. And what I'd like to do in different ways in this presentation will be, I want to register an account here. And so the first step is I go to the top right and click on sign in. Then I need to enter an email address. And this is romeo@shakespeareframework.org. Then I need to click that button. Eventually, this form will load. And then I need to enter some personal information. Yeah, let's speed that up. And then a full US address. And then I need to click register. And eventually, I'll end up at the profile page. And that's it. I want to make sure that I end up here. I want to make sure that I'm logged in the end. Okay. So what can we do to do that? So I will use Java and Selenium. You can easily translate most of the code to Python or to JavaScript, but I hope you get the gist of it. So one way to do this would basically be I use the WebDriver and I directly interact with the browser. Why not? So let's take this as a baseline. So the concept behind that is basically I have a test and that should interact with elements on my screen. For example, that input field for first name. And in that case, the test owns all the stuff that's needed for this test. So I have the tools like the WebDriver. I have locators in there, which basically tell me, okay, how can I find this element via the WebDriver? I have interactions like click on that, send those keys, click on that, click back, I don't know. So wait for something. This is basically what I mean with interactions. And then I have the state of the system under test that I also need to represent somehow, sometimes in the test. So for example, have I navigated to a page already? If not, I cannot expect that thing to be there, okay? So, and then if the problem here, of course, is when I write a second test, I will have the same stack in that test. And so I'm destined for code duplication. And when anything changes with the system under test or with my code, then I would need to change that in various places. But anyway, let's look into the code. So here's my test. My test should test the registration process. So I have an email already, and I can get the automationpractice.com website. So in the test body, you can see the WebDriver, and in the test method, you can see the state that I kind of have to manage. So at first, the browser is at about blank, maybe, and after I do this, I will be in a different state. Right, and then I start to interact with things. So I find an element by its locator, and then I click on that, and so here is my stack complete. I have a locator and an interaction. Right, and then I go on. As you can see here, we have our first waiting code. So we need to wait for this to be clickable, otherwise we'll get an element not found or an element not interactable exception, which is always nasty. And then we click on that. And now code multiplies a bit because these forms are so big. And then we have another big form, and we fill that. And in the end, we click on that register button. And in the end, we do some assertions, like we find the elements, like the alert class, that so any error message that would have been displayed at the form would have been in a div having that class. So I expect that to be empty. And then I expect no sign-in link, which is otherwise omnipresent on the website, is displayed anymore. There are different ways to assure that I'm logged in, but this is my way. You can choose another one, of course. Okay, so this is direct interaction. This is the most basic form, I'd say. And we end up here with 48 lines of code. In total, it's all in the test. So I have 48 lines of code in the test, but also 48 lines in total. And I have one file that I need to worry about, the test file, right? But when I create another test, that will be quite similar to this one. So it will, like, if one test is 48 lines and I have 10 tests, then I'm likely to have 480 lines of code already. So this is not a very sustainable way to do things, but I just wanted to introduce you. This is the basic thing. And the good thing about this is basically when I debug this, there is no hidden layers. I can see it all on the surface, and I can see, oh, this locator doesn't work. So this is why I can't send keys and stuff like that. But I can't go in there easily. Right. So in the end, this code, Shakespeare might have said, you speak an infinite deal of nothing, from the Merchant of Venice. Okay. So let's look into another common approach, which is called page objects. So page objects is quite known to many of you, I guess. Basically, we have a test, and instead of directly interacting with the website and the elements on the screen, we use a page object, and that interacts with the elements on the screen. So in that case, we keep the state and the tools mostly in the test. We also share it with the page object, to be honest, but that's a detail. So the test manages the state and the tools mainly, and the page objects take care of interactions and locators. Right. And if I now have another test, I can reuse that page object, and I have less code duplication, of course. Right. So let's look into the test again. In this case, we do many things similarly. So the first two lines are basically the same, But now we create a homepage object. And instead of looking up that button, we say a homepage, please go to sign-in page. And then we get a sign-in page, and then we say, sign-in page, why don't you start registration? And that basically does all the interactions that we saw before. And now we have a register page, and that register page we can ask, I'd like to enter some personal information, and I'd like to enter an address and give that data to it. And and then I can say register page, I'd like to submit you, and that's basically it. And in the end, I can just ask the register page, hey, do you have any errors? And the home page, I can ask, am I logged in right now? Right. So details like locators and how I'm actually doing all this stuff, that's all hidden in the page object. For example, one particular nasty bit of code that we used to see in the test before was the entry of the birthday, which requires to select from three select fields a certain integer stuff. And here I just say, yeah, my birthday is Valentine's Day 99, you know, I'm Romeo. Of course, I'm born on Valentine's Day. So this is one way to do this, to hide the details. And now my test is much more readable. And here we can look into an example of a page. I use modern Java here. Don't be scared. It's a record. Yeah, that's really cool. And what I'm basically doing in a page object is I delegate the WebDriver to it. And I have most of the time, a lot of people at least do this. They have these locators, these Y objects in the class body as constants, because those never change no matter what state the WebDriver is in. So I can just do them statically. Some people tend to do this. I'm not sure if that's a good practice, but anyway, so in the constructor, I can just wait for certain things to happen to make sure that I don't use this page before it's really ready to be used. I tend to do that in the interaction methods themselves, but this can lead to code duplication again, because I tend to wait for the same thing over and over again. Anyway, and then I have this start registration, which is basically find that register, input email stuff, send those keys, and then click that button, and then just return a register page. Right. As you can see here, up here are my locators. Here are my interactions. Nice. Especially nice is that start registration is not like a confusing thing, sequence of interactions, but rather something like a intention. I'd like to start the registration. This is what I want to do. So from test's point of view, I can see, this is what I'm doing. And I don't need to, you know, pull one and one together myself, but I see, this is my intention. Okay. And yeah, if we now look at the test, we end up with a much more readable test, I think, which expresses a lot more intent. And if I do something like, okay, let's change, for example, I don't want to register a Mr. but a Mrs. So, or I'd like to use an invalid password or something like that. Then I can easily copy this test and change that detail and have another test. And that would raise my coverage and mitigate my risk of screwing up. Right. Additionally to the test, of course, I have the page objects, which are three: the home page, the sign-in page, and the register page. So I end up with like 28 lines of code which is 20 less than before. But I have a total number of lines of code of 130, which is 28 more, actually. And of course, I end up with 3 more files. So the trade-off here is my test is way better readable. It expresses intent way better, but I have more lines of code for now. If I multiply the number of tests, I'm pretty sure we will, like after 6 tests, we will probably hit the even. And if you have a test suite of like, let's say, you can easily end up with 50 or 100 test cases, then it will definitely pay off. But first of all, we get a multi-layered test. Like when something fails now, I need to dig into the code. I have one more layer I need to dig into, and this might be inconvenient. It might lead to confusing error messages and some more, time that I need to spend to analyze failures, in my experience at least. Another problem is, or a good thing is, of course, I can reuse the page objects, but I also need to change them. If I now add a checkout test, for example, I might end up adding more things to the homepage. Those are meant for the checkout, not for the register tests. And if something changes in any of these use cases, I'd need to go back to the homepage and adjust that again. So the number of reasons why, for example, the homepage is always the most terrible thing regarding this. The number of reasons for the homepage to change are quite plenty. And this is sometimes a problem because you don't know, why is it located here? Where do I need this interaction? And also when you write a new test case and you want to reuse that page object, then you reuse an interaction. But that interaction was meant for a different thing. For example, maybe I was convenient and I just skipped that empty string here, which is the second address line. So now I want to have a test case where I do have a second address line. Now I need to adjust this, but only for this one test case. So it's a bit abstract, I give you that, but if you have more than one reason to change some code, it's kind of an issue sometimes, and you might end up with unwanted changes, and you change something, and then somewhere really different, something fails, and you need really a lot of time and experience also to analyze why the hell did this happen. So it's generally a good thing if something only changes for one reason. And also, what I don't like here, this is an ideal I have, is I want to have a language which is like user-centric. I like user-centric tests. Like I can say the user does something. What we most of the time have in tests is some implicit, whatever's written here, the user does it. Sometimes that's not true. Sometimes we have multiple users involved. Sometimes we have multiple roles involved. And this is something that's really hard to express in such a test when we use page objects, because our notion is like there's only one actor in this thing, and they only do this sequentially. And there's no parallelization and nothing like that. So not too bad for simple tests like this one, but also an issue might be if we have some intent that spans multiple pages. For example, we have here this quite unneeded step where we step over the sign-in page. Actually, we want to start the registration process, and this means nothing here. Go to sign-in page and then start registration. So this is an extra step that's actually not needed per se. Okay, so Finally, let's look into something new that you might not know, and that's screenplays. Screenplays is a bit more complicated. So let's first change the term. We are talking about a screenplay, not a test. And a screenplay directs an actor, and an actor has abilities that enable these actions that we already saw to interact with elements on the screen. So a bit more around the bend, and a lot of people stop listening now because they think, look, they made it complicated. And yeah, at first that seems like that, definitely. And it certainly isn't an approach that's reasonable for small test suites, which have 10 tests or something like that. But bear with me, it might be worth your time. So in this case, we put a lot of the state into the actor object and the tools into the abilities, which are ultimately managed by the actor. And this is what our test would start like. So first of all, we don't interact directly with any WebDriver or something like that, but we create a new actor named Romeo. And there is where we will put in a lot of state and also data later on. And we can say that Romeo should be able to, with the can method, browse the web, and we give that a WebDriver supplier, in this case a local WebDriver supplier, so it will use my local Chrome basically. There's also a Docker WebDriver supplier. And we also tell it, okay, this is this is your base URL we are going to interact with. So here are the tools are basically managed in that browse the web ability. Right. So those are the first two concepts of screenplays. Simple enough, right? And now where do we do things? Where do we interact? So the next concept, the third concept, is an actor can perform tasks that are made up of these actions. So we have now, again, the ability to group things together, a bit like we did with the methods on the page objects before. And also, again, like that, we have the interactions and the locators in those tasks. So next step would basically be Romeo does, and then we create a task object named start registration. And that needs an email address, of course, because we need to fill that form. And on the lower right, you just saw what you saw before already. We're clicking that sign-in button and so on. So what does this task look like? First of all, the task implements an interface, which is named task. And it can have whatever number of parameters you want to add. In this case, only an email address. And in order to implement that task interface, we need to override a method named perform as, and it gets an actor as a delegate. And as a first step in here, we use the browse the web ability. So actor uses browse the web.class. And then we can ask that for a WebDriver. And by the way, only here, a WebDriver would actually be created. One issue with Selenium tests is oftentimes that the browser pops up as soon as I start any test, even though that wouldn't be necessary. And in this case, it only happens once I use this ability and get the WebDriver, actually. Then, so now the browser opens. Then I can now just find my elements, and I do basically the same things. I have the locator, I have the interaction, and do the other stuff as well. Two things to mention. We could use different abilities. We could use multiple abilities. So one thing that I do, automating our huge grocery shopping shop online, is I interact a lot with APIs besides interacting with the UI. So I can set states, I can verify changes using the API. And for that, we have a call HTTP APIs ability, for example, where we can get a client to interact with some APIs in the background, right? And also worth mentioning here, now we have this start registration, and it spans actually multiple pages, because I don't care which pages I'm on. This notion of a page is no longer relevant for a task. A task can span no matter how many pages it likes. And what's great here is that these tasks tie interactions like clicking that button, sending those keys, and so on, to the intention to start the registration process. So this is quite verbose. This tells me what I wanted to do, what I wanted to achieve, and it makes my tests much more semantic, I think. And we can go on with that by entering personal information. This is another task. And then we enter the address. And then we submit the register form. Okay. But, well, this is nice and well, but how can we confirm the state of the system under test? We don't know that right now. And if you paid some attention here, this is void. I don't have anything that's returned from a task. A task just does something. It does not return something. It might throw an exception. For example, if an element wasn't found, just like you're used to as a fellow victim of Selenium and browser automation, maybe. But we don't have anything in return that makes us understand what the system under test look like right now. Okay, so here's another concept, and that's called questions. An actor can ask questions about the state of elements on the screen. Okay, so let's add another line. Assert that Romeo checks login status is true. Simple enough. And a question is pretty much like a task, but it implements another method called answer as instead of perform as. And what this does is we can do the same things here. We can use the browser web ability, get the WebDriver out of it, and then find elements on the screen and just check, in this case, are there any sign-in links displayed on the screen right now. So questions can use abilities as well, but return some info about the app, about the system under test. And so we have a complete test now, or a complete screenplay. Apart from the 28 lines of test code, we have the start registration task, the enter personal information, enter address, and the login status question. So in total, we end up with the same amount of lines of test code, but we have only 108 lines of code in total. And we have only one more file to look into. To be honest, this is a bit cheating because we are using a framework here named Shakespeare, which is on GitHub, and you can use it yourself. I'll go on about that a bit in the end. So there's some code hidden. And before that, we were only using Selenium with no framework at all. But that wasn't goal here. I didn't want to save a lot of lines of code, but rather make the test more explicit. The problem, you might say, here is I now need to dig into another layer. So I have the actor, and then I have the task, and then I have the interaction. So this is a bit more complicated. Yeah. Okay. Good thing is tasks and questions are reusable, and they are pretty semantic. They pretty much say what they are doing. They don't need to compromise with boundaries of pages or something like that. They serve only one purpose. So if I change, for example, a login task, that will only happen because the login process changed. Whilst the sign-in page here has different purposes in the system under test. It has this purpose of logging in, and it has the purpose of starting the registration process. And it might have other purposes as well. For example, a forgot my password function or something like that. So the good thing is with tasks, I can really say, this is what I want to achieve. This is what this will do. The parameters that this will get are only for this one purpose, right? And if I apply tricks here, like waiting, like complex interactions, so sometimes you need to hover something in order for a button to appear, that will only be applied in context. Like I get to a page, I don't care about pages. Now I wait for a specific element because I want to interact with that. If I don't want to interact with an element, I will never wait for it in the task. Whilst in a page object, sometimes I do that. Okay, 5 minutes left. I will go into one more tiny concept, which is actually an extension. I didn't invent screenplays. This is, for example, the reference implementation by John Smart and several other great people who invented this is Serenity BDD. And they invented this. And I think they already added this concept, but it is not in the original, let's say, manifesto of screenplay. And this is facts. Facts can be learned and remembered by an actor to enable questions and tasks. So why do we need this? So let's reduce this test a bit more, because sometimes, especially registration, there may be a lot of tests regarding that shop that require a logged-in user, right? So this is a recurring problem with tests with complex web applications. You need a logged-in user, but you cannot reuse an account because you don't want to rely on that, or you need a fresh account with an empty history, maybe, and hence you need to register a lot of times. And also, what's annoying here is in the test code, I have now a lot of data. Like I have an email address here that might mean something or nothing. I have this personal information stuff. I have the address here, and the address needs to be a valid US address. So not easy to come by, especially for me, as I'm German and I have no idea about US zip codes and states and stuff like that. So what I could do is I can just create fact objects, I call them, which is basically a marker interface only. So this is a basic record wrapping a string, basically. And I can, instead of using the email address here as a string and putting that to start a registration, I can just say, hey, why don't we use a default email address? And we have that here in the email address fact class. And we can also do this for the personal information, like having another default. Could also be a data generator, like some random personal information, and it would just have some randomness in the name or something like that, or in the address the same. And so I reduced this a lot. The test code, the verbosity is reduced a lot. And if I really don't care what data gets in, and if it has nothing to do with the direct test output outcome, I can just use defaults. And this also expresses something like, I don't care about this data. It's not important. Don't look for this data. It shouldn't matter. So, right, I can use constants, I can use generators, I can use builders. For example, I can do something like, hey, give me some random address, but it's really important that the zip code is this one, or something like that. So in that case, you can say, I don't care about most of the address, but this particular field, that particular property, this is really important to me for this test. Right, and here's another thing with this test. So these tasks that we have, start registration, enter personal information, enter address, and submit registration form. So enter address relies on I am on the registration page. So these tasks aren't actually independent of each other. If I start them in a different order, this might fail due to a confusing reason. And I don't like that. I like top-level tasks to be really independent. I can start them no matter what state my application is in, but a completely nonsense state, I can start a task. So let's group these tasks together to make more sense. And we could end up with one register task. And the issue with that would be, now the register task would need default the email address, the personal information, and the address. And that's a lot of data to put into one task object. And also, maybe I need these data for different tasks, and I would need to re-add them. For example, the email address might be usable to log in as well. So I'd like to have them for different tasks at different occasions. So what I can do now is I can set up an actor to know these things. Like, you know your email address, right? You probably can know them by heart, your email address. So why not assume that an actor knows his email address as well? Or their address, or some personal information. I mean, that's basically the definition of personal information, that I know it. So what we can do now is create this register task and just say, hey, actor, you remember your email address? Well, put that and use that to start your registration. Do you remember your personal information? Well, use that and the address as well. And we're done. Pretty much the same as when we use abilities, we can remember facts. Right, and so we end up with a real concise test. And we could set up this actor in some kind of super test or super test interface where we set them up for certain tasks. So we might have a locked-in super test, and that would just know their credentials, for example, and so on and so forth. So one issue, so at least here you might say, okay, but how the hell would I debug this? This is terrible. I mean, this is 3 layers down, and it could be the facts, it could be the tasks, it could be, whatever. And well, to mitigate that problem, well, on the one hand, we have a real concise test now, and we can reuse this macro task to really do complex things here. So we can add a reporter, and this will output something like this, just for demonstration. So it will output the Romeo does start registration, how long did it take, and so on. And also here for the questions, it would output the answer. And if there was an exception, that would be output, and so on and so forth. So this makes it much easier to dig into what happened. Also, other ways, it's plain Java code, so you can dig into this with IDEA debugging or something like that. And also, as we're doing semantic things, we also have a semantic context in which an error occurred. Okay, so little conclusion. Readability. I do think that screenplays are really well readable. It's also quite understandable what we do there. I can dig into things. There might be a lot of layers compared to page objects where I have only one. But the good thing is I can group things together so they make semantic sense. Reusability, yeah, I can reuse a lot of that code that I write for one thing, but only if it makes semantic sense to reuse it. I won't reuse stuff that was not meant to be reused. I think, in my experience, this is quite maintainable, especially when you work together with different people from different teams with different coding styles. So they have their tasks, and they don't need to share code. They only share the ability, and the ability is usually provided by the framework maintainers. It's also quite debuggable as it's plain old Java code. The reports are in place. We also have a screenshot reporter and an HTML snapshot reporter. It's quite changeable, and it's extendable as we can just reuse tasks and basically use them as Lego bricks to stick together new tasks. So just quick further reading and implementation. So the inventors of Screenplay, as far as I'm concerned, they've written this page objects refactored article, which is the kickoff idea. I think it's a bit nerdy. You need to understand a lot about what are solid principles in order to understand this article. But their implementation is basically Serenity BDD, which is a huge framework. And if you just like to dig into the basic concepts of Screenplay, I can recommend my own work, which is the Shakespeare framework. I created that basically for this talk and the workshop that I do for this regard. And yeah, it's just the code that I've shown you. That's basically Shakespeare framework. And also I can recommend nosweatshakespeare.com, as this is where I stole all these Shakespeare quotes, because I'm not a big Shakespeare knower, to be honest. Okay, that's it. Thanks for listening. Right, this is a blank page. That's interesting. Okay.
Thank you very much, Mikael. I think we had some very nice feedbacks from the audience. Unfortunately, we are a bit late, so we'll need to skip the Q&A. But feel free to answer the questions directly on the YouTube chat, because we had some questions from the audience. Thank you again, Mikael, for your participation, and see you in a bit, I guess.
Yeah.
Okay, so the next and last conference is our panel discussion. So Christophe is going to join me. Hello again, Christophe. Your mic is muted.
Hi again.
Perfect. So I will let you introduce the topic and the speakers. Have fun.
Okay. So, hi Jan. Hi Frédéric. Hi Misha. Hi Iman. So, let's start with simple things. I propose that every one of you would introduce themselves. Ladies first. So, Iman, what about you?
We'll lose Iman.
Iman, where are you? So, okay, let's start then with you, Fred.
So just a short introduction, because I think the idea is not to introduce ourselves. So I'm a test manager in Amadeus. Iman.
Yes, sorry.
So I continue, and I'll let you the floor. So I'm a test manager in Amadeus. I don't know if you know this company, but Amadeus is the first GDS in the world, and I'm working in quality since 22 years. So it's a long life in quality. And today, in charge of the security, part of the security, especially for PCI DSS, the possibility to use a credit card in our company, and the other part is to I manage the quality community inside Amadeus. Part of the quality community, because we are more than 600 people in this community. And another important topics, I'm also the organizer of the GFTL, the Journée Française des Tests Logiciels in France. So if you want to participate, you're welcome. The inscription starts, I think, last week.
Okay, and when is it due to happen?
In in Montrouge, so very close to Paris. So if you want to join us, Paris is a beautiful city.
In June, that's it?
In June,
14th.
yes, it's 14, yes.
Okay.
We have a day for the workshop on Monday and the presentation in Tuesday.
Okay, see you there, Fred. Iman, the floor is to
Yes.
you. Present yourself,
Hello,
please.
Christophe. Hello, everyone. Thank you. I'm very happy to be here. So I'm Iman Bellekal, Director Expert here in CGI. I'm also responsible for the practice of the quality assurance for all our global delivery centers. I don't have that much of years, but I have 15 years of experience in this job. It's a real passion for me since I discovered it. And I've worked in Europe. I had the chance to work in Europe and the chance today to work in North America, in Quebec, more precisely. I've done various sectors, so I have a global view of the challenges. And it seems that we all have the same challenges, whether the area.
Thank you. Misha, you did a great presentation, but well, can you go further regarding your own character, your own you?
My character, yeah, I'm real grumpy. No, well, so I started as a developer, and I was really fed up, like fixing bugs, like spending weekends, cleaning up my own mess and my predecessors. And that really annoyed me, and so I dug deep into quality and continuous integration, and then I was encountering Agile and also Lean, and recently I read several books by Jess Humble and so on, but like you mentioned already, Accelerate especially. And yeah, now I'm deep into metrics and how to measure actual quality and stuff like that. So this is one of my big topics, and the other one is really like I'm done with fixing software. I like to fix developers, basically. The fix processes.
Trickier job.
Yeah, it's tough, but to be honest, it pays off a lot better than fixing software, because when you need to fix the source of the bad code, right? And I'm not saying the developers are producing only bad code, but sometimes it's really due to not knowing certain things, and I try to fix that, basically. So this is one of my major approaches, and probably also the reason why I'm currently reading a lot about cognitive biases and so on and so forth. Yeah.
So
Thank you,
you mean a developer is a bug generator?
Yeah, that's one definition.
They're responsible for that, but they are not accountable for this. This is the PO, basically. Yeah, maybe. What about you? This is the second time that we meet.
Yeah, indeed. Good to see you back. But basically, I'm happy to hear Misha, because I have exactly the same thing. I started off as a developer yada yada, went into project management or whatever. In the end, I said the only thing I can do is coach, and now I coach people so they can grow, because basically that's the only thing that counts in the end. And that's the fastest way forward. So now I'm an organizational coach, and what's in the name. So I help clients to get organized, to create the context where people can do their job, basically. And that is lacking so much. And there is so much gain to be gained from creating the correct context. And most of the problems will be solved.
Okay. So I propose that we would deep dive into the topic that we are here for. That is to say, what is the success criteria for test automation in an agile context? Who would like to start? Is that raised up, Misha?
I can start if you want. One of the success criteria is everyone to be aligned on the purpose, first of all, of the automation. The most problem, the biggest problem I have faced and I have seen is one when everyone has his own view of the objective of automation, and obviously somehow and at a moment there will be a huge problem. So I think the alignment of the purpose of automation is important to start.
Okay. Anything to add, guys?
I would like to add, and one thing that disturbs me, it provides me a job, but anyway, is architecture. I mean, if you have a crappy architecture, if you have one big blob, let's say, I mean, you can try to pull out any trick in your sleeve to do automation or testing, it will fail anyway. You will have crappy code. If I mean, with good architecture, I mean loosely coupled. If things are not loosely coupled, it gets so messy, it gets so complicated that whatever you do, it will fail. It will fail sooner or later, despite any technology, any test coverage, any test framework. That's one of the things that I like to stress. And the second thing I want to stress is professionalism. I mean, software development is not that old as a craft, and you can see it. I mean, it's not fully grown as I experience it. I mean, when things have to be correct, really correct, then, for example, like in finance, what do? They have double accounting, double entry. So they do twice the same thing, and in the end, it has to match out. And when it really matters, and in software development, well, we just do it once and we pray for the best, and maybe we have some tests to check it out, but in the end, we treat testing a lot less than we treat development. I mean, it should be equal. It's the same thing. I mean, it should be twice the same thing, and twice equivalent. Of course, taking into account what is the quality you want to have, and if it doesn't matter too much, just develop and have some unit tests and end of story. If you take it seriously, then you have to do other stuff.
I've seen actually that Misha provides something like a way between this testation and this coding manners, because screenplay, well, actually I knew the screenplay stuff before you did this great talk, and I realized that screenplay is actually the solid version of this page object model. And what do you think about this equal treatment that would be pushed to this automation stuff and regarding communication between people, Misha?
Sorry, I didn't get most of what Jan.
Okay, sorry.
But, so please don't
repeat.
Yes, okay. I meant that this screenplay approach is actually mixing development techniques, because this screenplay technique is actually a solid version of this page object model, and therefore I suspect that you would have something to say above what said Jan.
Yeah. So basically, what I think is we should apply good development practices to test code as well, because at the end, the test code is really a product in itself. It provides you, especially in my context, where we have like 40 teams that produce microservices that end up being one big product. And the test suite that I maintained for a long time, currently it's in other hands, and maybe that's for the best, is something that provides some certainty and risk mitigation for all the other microservices, and it really doesn't have anything to do with their code. It's just you can change the whole thing. And what it ensures is basically that the basic feature of the product as a whole still work. And not applying good coding techniques to these huge test suites that have a lot of dependencies, hidden dependencies and obvious dependencies, is destined to fail. We should do that. We should not overdo it. I mean, that's what I saw, and this is what I already did. You can create God patterns everywhere. So again, a reference to a dark pattern in development, and you should be sensible to those. So yeah, I think architecture is something that needs to be applied to tests as well.
I agree. Fred, on your side, since you are in touch with several hundred of people that do practice testing by your company, what have you noticed regarding those criteria? Are they are people aware about those two challenges, communication and architecture?
For architecture, we have some test system in place since a lot of time. You know this, Christophe, and so it's not really a problem since the beginning. But we start to move to the cloud platform since 2 years or 3 years. So it's not achieved today, but for testing purpose, it's a big change because we don't have the same platform. We don't have the same context, and it's very tricky to update our test environment and our test automatic tests in this platform, especially due to the fact that we don't have the set of data we have previously. So it's very complex for us to manage, especially because before we do a capture of the production data. You can imagine the big set of data we have for airline company and rail company, etc., etc. And we have some filter to anonymize the data, and it's not possible to do exactly the same in the cloud environment because it's too costly and it takes a lot of time, so it's not possible to do this. So today we have a big migration about your test campaign in the cloud. So it's the big challenge today. And to reply to your question, we don't have today an homogeneity of the KPI in Amadeus. It's for some teams we have some a set of KPI, and for some of our team it's another set. So we have some KPI in common KPI, but it's not in the Amadeus purpose to have a standard set for everybody.
Okay. So it means that actually every part of the company is trying to struggle their own way to achieve what is required.
Yes. So it's not. We don't have the same level of quality in all the different group, because we cannot manage an airline like a hotel or like airport. So it's very complex.
The lack of standard due to sharing the same goal, or is it just because each business does not address the quality level the same way?
Alors, it's we have two problems. The big one today, it's we have less and less people for QA. I don't know if it's the same for everybody. So it's very difficult to progress on this area, especially due to the COVID. I think everybody are impacted by this. How to say this problem, and also due to the market constraint today, it's very difficult to recruit new QA people. So it's why it's very complex to have to progress on this area.
Iman, I suspect that you have some kind of trick in order to let the whole company, whole organization move towards some quality standards regarding automation or whatever the topic.
Well, one of the main clue is to make people understand the importance of quality and why automation can help us reach this the level of quality. It's still an issue here. When I say here, it's not in my company or in one client, but most of what I observed is people want to make some things, some products, a quality product, but they have the wrong solution. Sometimes they say, okay, we put automation and this will solve our issues and will bring automatically the quality. So this is why in the beginning I started by saying that most of the problems is understanding the purpose of automation. So I think the first thing we do when we speak about automation is how to understand, and do we want to reach the same level of quality with all people, not only the service, the program, the developers, it's with all the company. So I think this is very important for us to understand and to make understand the top managers, for example, other services, that the quality is not only the development's responsibility and the product itself. Fred, you said that we are having less and less QAs. I agree. It's not that we have less and less QAs. It's that the information, the technology are more and more taking place in our world. So obviously we have less developers, we have less QAs, we have all these engineers much less. So this is my first approach when I speak about automation and quality with our clients.
And what would you suggest as a hint, or tip, or whatever, to overcome those communication or architectural or quality level standards?
It's not easy. It will depend on the knowledge of the client and the person with whom we are working. So of course, the more people understands quality, you can take him as a sponsor and try to prove that it's important. I try to prove that it's important not by proving the quality, but proving the non-quality. Today, I think the social media and the news are helping our profession to prove that it's not good to have a bug that will impact many users. So by these references, sometimes you can catch the attention of the top managers. The top managers speak somehow two languages, or they are very sensitive at two aspects: money and image. So if something hurts their image, obviously they will try to concentrate or try to understand more what you are saying. So for us, QAs need to be this bound between the IT departments. Even if I don't like the departments, we need to be a whole working all together, and the rest of the departments. We need to try to make sure that everyone is understanding the objectives and the problems if we don't have a certain level of quality.
Jan, maybe some reaction? Yes, Misha.
Yeah, so I hear you totally, Ivan. This is also the questions that I asked myself for a long time, and I was furious, like, why don't they listen? Why don't they understand and stuff like that? And recently I stumbled upon site reliability engineering, and this is really awesome to read. Like you sit down with the product people, with management, and just what you said basically. So we get together and we decide this is the amount of quality that we need, and it's really hard to quantify quality. I mean, listen to what I just said: quantify quality, right? And what Google suggests is basically, okay, this is the amount of reliability that we need, because if reliability is bad, it does really not matter how great your UI looks. If it's not available 10% of the time, nobody will use it in the end. And this is, I think this is a real nice approach to just sit together and say, okay, this is reliability that we need 99.9%, because that means like we can be offline for that amount of days a year, something like that. So everybody understands that. And a lot of managers seem to have this image in mind, 100% reliability is feasible. And every developer knows, I can pretend that, but I can definitely not deliver that. And the only service, I think, on Earth where everybody agreed this is 100%, a real 100% availability service, that's the HTTP service run by Google. And they say that they have a massive redundancy for that thing because it does fail. It is not reliable all the time, but as it's so redundant, they can compensate that. Well, that's the only way to do it. And they will never change anything on that thing if it's not totally necessary. So what managers want all the time is the newest, greatest features. On the other hand, they just implicitly expect you to deliver 100% reliability. And they really don't. And when you get into their perspective, it makes sense, because nobody told them that's impossible. But it is. Any change introduces a risk for an error. So you cannot change a system that needs to be 100% reliable. So let's put a price tag on reliability and on quality and say, okay, this is the trade-offs that we need to make. And if we reach our reliability error budget's bottom, you will not get any features for this quarter. This is a red line. Up till here, we need to invest time to stabilize the product. And that's what you signed. This is the contract. So I like that approach.
Carry on, please. Okay, Jan, do you have some feedback on your side from coaching directions and people around them?
Well, I think Micha nailed it when he said you have to if you speak to managers and you want to convince them, you have to speak what they're interested in. And if they're interested in money, you have to talk about money. If they're interested about a good name, then you have to talk about that. I mean, whatever will impact, whatever will hurt them if something bad happens. I remember one moment in time when there was a big program going on, and the program manager had an issue. He said, Jan, I can't get any testers from business side. I mean, they just are not available. I mean, they want their features, but they and I was working with him for some time, and I said, okay, let's bring the big guy in. I mean, the guy that should, I mean, the business director that should give the go for business testers. And I said, let him in, and we'll show him our visualization of work. So it's all about visualization. And he came in and we showed him the program and the advancement of the program. And it turned out that the program was near the end of the budget and the time it was given, and yet it did not deliver a lot. I mean, we had a Kanban in the last column which said, I mean, delivered to business. There was not a lot of stuff. And I was explaining that to him, and he said, yeah, that's exactly what I was thinking. I mean, the budget is nearly done, the time is up, and you didn't deliver. And well, I said, yeah, that's true. And then he pointed to the column that was just beside the done column, and there most of the in the time there were still physical post-its. That most of the post-its were hanging, and he said, look, who are the dumbasses that blocked me over there? And that, of course, was the moment everybody started to stare at his shoes, because the title of that column said business testing. I mean, he understood at that moment, I'm blocking my own work. And 1 week later, they had 10 testers. And the program manager, he didn't understand. I mean, he said, I'm explaining that to him for more than a year. I mean, how is it possible? Well, he came to the conclusion himself. I didn't say to him, you don't deliver to me your testers. I mean, he came to the inside that. And that's what you want to have. They have to come to the inside. You have to provide the information, and they have to come to the inside. And that's the moment that things change.
How do you lead them to head towards automation?
I have no direct answer, but I mean, you have to look for them. What is their interest, and what could automation? How could you link automation to what's something that is in their interest? And if you cannot make that link, then maybe automation is not necessary.
Okay.
Or you didn't do your job well enough.
Misha, you were about to say something?
Yeah. So automation is just a tool, right? I say, okay, we'll take. It will take this long if we don't do automation. Usually it will be faster if I skip automation at first. But on the long run, we'll just fail. So as for automation, I'd say this is an engineering responsibility. I know that management expects me to deliver roughly the same time. So something like this curve, right? In the beginning, I'm really fast because I'm on a green field, and then it will stabilize. I will have a stable lead time. This is something management expects me to have. I don't know when I hit it. I don't know when I have it, but this is what I want. And if I don't do any automation, I'll probably have the exponential curve, right? I will end up taking indefinitely long to make the smallest changes. So I think the team needs the trust from management to do as much automation as they think is necessary to keep the pace. But on the other hand, management could do a better job in expressing their expectations. This is the pace we need. Sometimes they just drop a deadline on you, like in 2 weeks we need to release, and you say, if you didn't do any automation, if you didn't care about quality, you will be really scared in that moment. If you did sustainable quality, sustainable automation, and practice continuous integration and continuous delivery like you mean it, it will be just like, yeah, okay, but we don't have these crucial features because they were blocked till now. So that's okay to you, we can do that.
So actually, in order to speak just like managers would, share something about transaction costs, about every delivery processes, delivery attempts.
I'm not sure if I got that.
Well, doing some manual testing would cost much more than doing some already made test scripts.
Yeah, not necessarily. I mean, yeah, of course. I mean, that's a trade-off that you can do. If this is a one-shot product that will be trashed after it fulfilled its purpose, it's totally fine to skip automation. Probably not, because automation is also something that drives good design. Testability is often, in my experience, if you do automation like you mean it, if you do continuous delivery and continuous deployment, then you do certain things not totally stupid. If you rush development and you think, okay, we just need to finish this for 2 weeks and then it will be online for 3 weeks and then we'll trash it. First of all, those 3 weeks are often a lie. I did a lot of prototypes that ended up in production for years. But on the other hand, also you will do a shitty design. You will screw up things. You will screw testability ultimately. And if you do automation early and continuously, your design will be much better on a global scale and on a microscopic scale.
Comes to automation strategy that any one of you would promote in order to avoid is named the ice cream cone, of testing. That is to say, a lot of testing at the UI and fewer before. Someone that would like to share their own picks.
Christophe, we lose you sometime. Huh? I don't know if it's
sorry,
only me,
sorry.
but
Let me repeat. Well, I don't know if you guys know about the term ice cream cone. Sorry, about testing. It means that most of the time, since you have this kind of shape, this cone shape stuff, you have a lot of UI testing and very few testing beforehand. How do you promote the other way of testing? That is to say, avoiding this, but going this way.
You can choose the cost of the different type of test, of automatic test. If you perform automatic test at component level, I think you speak about the ESTQB levels. It's a small cost compared to the test, the UI testing, especially not only not for the creation of the test, because today we have a lot of tools to record the script, so it's very easy to create a script. But after the maintenance of the script is very complex, especially for UI code, and especially if you have not how to say, a legacy code, so a code with a lot of change. So in this case, the maintenance is very costly, and sometimes it's very difficult to explain to the management or to the product manager. Okay, we rewrite some tests. It's a first an initial cost, but at the sprint after sprint, we have a maintenance cost, and it's mandatory to plan this cost during the next sprint. So it's very difficult. But if you have a huge set of automatic tests at component level, because it's it's very close to the code, the maintenance is not costly like UI test. So it's something to discuss with to plan at the beginning.
Yes, Iman?
Yes, I agree completely. I had one project where we were not too much QAs according to the number of developers, and it was very hard. We did not have any automation at any level, not even in the developers stage. So we were definitely in this area, in this ice cream cone. To sensibilize the developers, the product owner, the project manager, is when we, after each closure, after each sprint, we used to say, okay, developers need to really test their own test. So the first step was to make developers test really more deeply their test. So little by little, they discovered by themselves that it was worth to automate these simple tests at their stages, because once we told them, like, for months, regression. Once we tagged all the defects as regression, and it could have been avoided, and that they block the coverage, the essential coverage that we are used to do, we're supposed to do, sorry, then the mindset started to shift, and they were pushed by the tech lead and the project manager and everyone. So now we are changing this icon to the pyramid. It's a way.
Well, it looks really close to Misha's SRE discussion. Yes, would you like to add something, Misha?
Yeah, so one thing is natural, in my opinion, is that you get the ice cream cone eventually. So it has a natural tendency to be like that, especially when you have specialized QA, because that top level, this is what pure testing, that the product people, they understand that. Those test cases are basically their user stories, right? So this is why you like these tests, because they prove something. Like, there's no doubt this is what this does. This test is valid, right? And if you have a unit test for some class, whatever a class is, right, and that tests a method with some parameters, I don't know what a string is, and so on. Well, that what does that mean? I mean, there's still a huge risk. I cannot figure out how big the gap from this test and the remaining risk is. While it's in the top level, I can say, okay, this risk is covered, nice. So what helps a lot in my experience is to get people like real good automation engineers, and they review their big test suites that take forever and just make suggestions. We could write a unit test for that, and we could do something for that. And also to have testers on board that really act like testing consultants. And they say, you have like 10 cases for this scenario. Like, you put in a invalid email address that's invalid this way, and then that one that's invalid that way. I guess you have a validator for that. So can we look into the unit test for that and just push like 8 variants down there and only keep invalid and valid on the top level? Because that will be much faster, and stuff like that. Also, a lot of ramp up is taking place in such tests. Like, I need to set the stage, initialize databases, and so on and so forth. So this is taking forever. So I really think you cannot avoid this bubbling up of test cases. You just need to counter. You need to constantly work on that. Like, it's okay if an acceptance test has to be created at first on top level, but when it comes to variants, you need to be really careful to, okay, let's look at the foundation. Let's look if we can strengthen the foundation instead of broadening the rooftop.
Red, you wanted to add something?
Yes, another way to motivate the developer, especially the developer, because it's very complex to motivate the developer to perform some tests. It's to use gamification. So we have a lot of tools proposed by some company to have a kind of game and to increase the quality. So it's the idea is not to control the guy via the game, but more to propose some challenge to increase the quality, to increase the quality in the code itself. So it's another way to increase the sensibility to the quality. So I don't remember the name of some tools, but you can find some tools in the market. It's not the problem.
Misha?
Just one thing to add that I just forgot. What made me really automate a lot of reasonable stuff was simply applying mutation testing. This is really a nerdy tool, I think. It basically mutates your code, like your production code, not your test code, and then runs all your tests. And it would do nasty things like exchange a plus with minus or return null instead of an
Yep.
object and stuff like that. So some tests should fail, right? If you do something like that. And if it doesn't, then you know what you need to automate still. So this really made me, I just did this blindly. I was just killing mutants, which is a nice gamification term, I think. Killing mutants all the time. And in the end, I was doing this blindly, not thinking, really only killing the mutant, writing the smallest test that would kill the mutant. And then I stopped and looked at my test suite that I just created in the past 30 minutes or so. And I was thinking, wow, this is what I would have come up with 10 years of experience of doing this. Wouldn't be much better than what I just created without even spending a thought on this.
Misha, have you ever tried the STEM project?
Yeah.
Okay, we have something like 2 minutes left. I was wondering about a connected topic regarding this automation matters, which is actually about test data and environment. Do you practice, do you promote any practice regarding this? Whoever.
Well, if I can combine it with the previous one, I mean, if you want to convince somebody, the best way to convince somebody is to be trustworthy. So, for example, how we did one of the things we did at TestGear is that we have an organization, and we have a project that is running for 10, 15 years now, and we have about 7% maintenance costs. And the speed of delivering new stuff is still at the same rate as it was years ago. So it's constant. So now we have our hands free to do whatever. So they believe us. So if we say we need test data, we get it. If we say we need test automation, we can do that. I mean, it's all about trust. If you can prove the value, you always win. You always win. So whatever you want, if you can prove that it works, you will get it. And one of the things indeed is not only test automation, but indeed making sure that you manage your test data. If you have to look for your test data each and every time, you will not be at 7%.
Any insight regarding this topic? Okay, so it's 6. Well, it's 10 past 6. So I think that we are over now. So thank you, every one of you, for your participation and for your brilliant ideas and tips. And Ima, this is your turn. Oh, Artie.
Hi, we're back. Thank you everyone for your participation. We had some great feedback today, some great engagement. So thank you very much for your sharing expertise and everything. Artie, do you want to say something?
Well, I actually, for once, enjoyed a really great lineup of keynote speeches and a very engaging panel discussion. I wasn't part of it this time, but really was following every word. I hope the people who were with us up until the end really enjoyed it as well. So thank you everyone for attending. Thank you greatly the speakers who were with us today. The recordings of this stream will be sent tomorrow by email. And we all really hope, we at Agilitest and TestGear really hope you enjoyed these conferences. So thank you very much.
Yes, again. I did. See you around.
Thank you very much, everyone. Have a good end of the
Ciao.
day. Bye-bye.
Goodbye.